How it's made. Solar panels are something that climate conscious cities and towns have made almost abundant and popular. The city from the sun is bountiful, and it makes sense that we have to develop methods to harness this large amount of energy. The earth actually receives approximately 25 times more power from the sun than we use in the world every day. The use of our energy has grown increase in the last decades. However, how are solar panels made? Welcome back to our channel, how it's made, and don't forget to drop a like and subscribe to our channel for interesting topics like this. The science behind solar panels. The whole basis of making solar panels is by using a superabundant material that we see on earth. It is sand abundant in silicon, and it has to be purified to about 99.999% purity. There is a very complex purification process to do this. If you were to look into the structure of the silicon module, you would see that the atoms are bound together where the electrons in the structure can't move. Only if energy strikes silicon can the electrons move. This is how a semiconductor material works. However, when the sun strikes, the movement of the particles is random and there is no current through the load, so you need a driving force to ensure the unidirectional directional flow of electrons. Boron is often infused into pure silicon to create holes for the particles to move towards. This makes sure some electrons would migrate into positively charged region and fill the holes available there. Because of electron migration, the boundary of the negative side becomes mildly positive charge, whereas the positive side becomes mildly negative charge. An electric field will form between these charges, and this produces the necessary driving force to move the electron in a particular direction. In a particular solar cell, the top layer is very thin and the abundant with electron, whereas the bottom layer is lot thicker. Solar are constructed in the particular way as it results in the generation of more current. The top thin layer also makes it more easy for sunlight to penetrate through. How are solar panels made? A solar panel has several layers. One of them is a layer of cells connected in series through copper strips, and it is what you often see immediately. Another layer is a layer of PVA sheeting on each side of the cells to protect them from the dirt, humidity, vibration, and shocks. To protect these light sensitive sheets. Step 1. Obtaining pure silicon and making wafers. The procedure to purify silicon from sand involving mixing carbon with it and applying high temperature up to 2000 degrees Celsius. You would obtain a gaseous silicon compound which is then mixed with hydrogen to get highly purified polycrystalline silicon. Scientists then change the shape of these silicon ingots and turn them into silicon wafers. Silicon wafer is the brain and heart of the photovoltaic cell. There are two main types of solar panels which exist. These are thin films and crystalline silicon panels. Crystalline silicon solar modules are very common and they look like black or blue rectangular grids having smaller scale shaped cells, and they tend to be interconnected together. There are two further types of crystalline silicon designs like monocrystalline and polycrystalline design. Monocrystalline cells can produce high electrical conductivity but are costlier. Polycrystalline models have more impurities but are cheaper. You can recognize a monocrystalline solar cell as a crystal framework produces uniform blue color without any grain marks. There are also thin film modules that adhere to the metal foil, plastic, or glass substrates. However, they can be fragile and sometimes flexible. This can be installed on automobiles and other devices. Step 2. Producing the ingots. Pure silicon rocks obtained are melting at a very high temperature to get the ingots in cylindrical shape. Melting process makes sure that atoms are perfectly aligned. The boron is added to give the silicon positive electrical polarity. After cooling down the ingot, the grinding and polishing process are done. The ingots will then have flat sides. Step 3. Constructing the wafers. The wafers are derived by slicing the silicon ingot into extremely thin discs. This process requires the use of a wire saw for extreme precision. Cutting a wafer is as thin as a piece of paper. Pure silicon is shiny. It can reflect the sunlight without absorbing any, which can be detrimental to energy conversion. Hence, in order to reduce the loss of sunlight, an anti-reflective is applied to the silicon wafer. Step 4. Making the solar cells. The wafers are converted into solar cells by individually plating them by adding metal conductors to each of their surfaces. Due to this, the wafers get the characteristic grid-like matrix on the surface. This helps in this conversion of solar energy into electricity. Also, the coating increases absorption of sunlight and reduces the loss of sunlight by reflection. Even phosphorus is diffused in a thin layer over the surface of the wafers inside an oven-like chamber, and this makes the surface get charged with a negative electrical orientation. The use of boron and phosphorus leads to the incorporation of a positive negative junction. Step 5. Cell cutting. Using a laser cutting machine, the solar cells are cut out based on the wattage of the panel, and the size of cell is determined for fuel cell module. This step is skipped. Step 6. Stringing process. This is fully automated process and involves joining the cells together to place them in a panel. A good quality panel employs cell of size greater than 38 mm, and the cells are joined together with the help of soldering. The other side faces the sun and usually comes in blue or black. This is the negative component of the bottom side is white in color and is the positive part of the device. Step 7. Adding the solar glass. Here tempered glass is applied to the panel and the glass has a coating of ethylene vinyl acetate. This is to protect the cells from external dirt, dust or even mold. Step 8. 2. Visual inspection. A technical inspector inspects the cell for any fault or error during the stringing process. This is important to ensure quality as the whole process tends to be automated. Checking periodically for quality is important. 9. Taping and connection. In this step, a technician joins the solar cell into a mixer alignment by taping. Connections between the cells are soldered together at the same time. Any excess material is cut out and removed. This ensures the minimization of the area. Step 10. Insulating the module. Connection and observation. The connections are insulated by employing a backsheet and EVA encapsulation. This protects the module from dust and moisture. The module is checked for any dust particle, color mismatch, and other issues. Step 11. EL testing for defects. EL testing is short for electroluminescence testing, and here the solar module is scanned in an EL machine. This identifies any dead or low power cells, short circuit cells, cracks, or any defects. In case of module found to have an error in it, sent back for fixing. Step 12. The lamination process. This process is about laminating the module at the temperature of 140 degrees Celsius. It takes only 20 minutes, and after that the module are left for 10 to 15 minutes to cool down. Only after it cools down to reach room temperature can the next step be done. 13. Framing the backsheet, frame cutting and frame punching. The excess material of the backsheet is cut and discarded. Frame cutting involves cutting out frames of various sizes for boarding the panel to ensure a perfect fit. After this, rows are made into the frame for mounting and grounding the panel to the surface. Step 14. Filling the sealant. The sealant is fixed to the solar panel to protect it. This also helps the module firmly get attached to the frame. After the frame is fixed to the module, this is sent back to the framing machine and punched into the frame permanently. Step 15. Fixing the junction box. After the sealant using process, the junction box is firmly attached to the module. After this, all the remaining connections are soldered on a kept aside for 10 to 15 hours for curing. This ensures that the step is perfectly dry. 16. Final cleaning and testing. The whole panel is then wiped and connected to check its output current and voltage and so on, so that a test report is generated. After following all the stipulated guidelines, or information labeled with all the details will be pasted on for the users. A quality control lab test is also done to check insulation resistance, after which it is sent for a mechanical load test. If it clears all the tests, it will be packaged and sent for sale to various companies or wholesale merchants. And that is the journey of a solar panel production.